Question 27, last question of bundle 10 module 1. X plus 1 minus 56 is equal to 4x parenthesis x minus 7. What is the sum of the solutions to the given equations? Okay, first of all, the given equation, this one, is not in the standard form. So let's convert it into standard form first. X plus 1 minus 56, 4x x minus 7. Let's apply distributive property here. So that is x squared plus x minus 56 is equal to 4x squared minus 28x. Okay, so that is a quadratic equation. Now subtracting 4x squared on both sides, we have to make it equal to 0, and adding 28x on both sides. So that is cancelled, is equal to 0, minus 56 minus 3x squared or negative 3x squared plus 29x minus 59 is equal to 0. Let's multiply the whole equation by negative sign, negative 1. So that will be 3x squared minus 29x plus 56 is equal to 0. Now, when the question is about sum of solutions, so solution always mean it's an equation and we have to find the value of the variable. It's a quadratic equation, so we have to find the values of x and then take the sum of it. Now, as it is a quadratic equation, we can solve it by factorization method or quadratic formula, or completing the squares, right? Completing the squares. Completing the squares is a little bit tricky. Quadratic formula is the formula which is applicable like every time. Factorization, when you have square root questions, right? For example, the roots are x is equal to root 3 or some irrational number. Factorization is a tricky in that case, and quadratic formula is applicable and convenient every single time. This question I'll solve by two methods, factorization and quadratic formula. So let's start factorization method. So that is the AC method, and here comes the product of AC, which is 3 times 56, which is 168. And here we write the b term, which is negative 29. So we have to find two numbers when added give us this negative 29, and when multiplied give 168. So let's say the numbers are negative 21 and negative 8. When you multiply them, you get 168, and when you add or subtract them, you get 29. So let's split it. 3x squared minus 21x minus 8x plus 56 is equal to 0. So taking 3x common, x minus 7, then minus 8 common, x minus 7 is equal to 0. Then this is complete 1 and complete second factor terms. It is term 1 and term 2. Taking x minus 7 common from both, we get 3x minus 8 is equal to 0. Now applying the 0 property, x minus 7 is equal to 0 or 3x minus 8 is equal to 0. So x is equal to 7 or x is equal to 8 by 3. Now we have to find the sum of the two solutions. So two solutions are 7 and 8 plus 3. That is our question. Now this one I am doing by making the denominator same. So that is 3 sevens are 21 plus 8 by 3 is equal to 29 by 3. We have found the solution with the help of factorization. Now second method I will do and use the quadratic formula to calculate the zeros. So that is 3x squared minus 29x plus 56 is equal to 0. Quadratic formula is x is equal to negative b plus minus b squared minus 4ac by 2a. Now, if you are comfortable, directly apply this formula here. But if you think, it happens, sometimes calculation error happens. So we can do one thing. We can calculate b square minus 4ac here, and then we will plug it here. So what we have done basically, divided the calculation into smaller parts. So b squared minus 4ac is negative 29 whole squared minus 4 times 3 times 56. Okay, calculator is allowed. So that is equal to 13. Now I'll write this formula here. Negative b plus minus square root of b square minus 4ac by 2a. Negative b is 29 plus minus 13, and by 2a, a is 3, 3 to the 6. So two roots are 29 by 6 plus 13 by 6. This is the first root. And 29 by 6 minus 13 by 6. This is the second root. And we have to find the sum of the two. So let's do it. Now if I find sum, these two are cancelled and I am left with 29 by 6 plus 29 by 6. So that is 2 times 29 by 6 and it's 3. So 29 by 3. Now I have done it here by factorization and here by quadratic formula. These are two different ways of calculating the values or the solutions, but answer will remain the same. I hope you get both of these.